Good morning, everyone. So now we'll be starting with the second session of syllogism. Okay. Now where we'll be discussing how to solve questions, particularly through the examples, how to use Venn diagrams to solve questions on syllogism, and we'll take up all types of all varieties of questions to understand everything about the problem solving in case of syllogism. Okay. All right. So the goal for the class would be first of all to learn how to use Venn diagrams for solving the questions, and second is to discuss problems, no? To understand how to solve problems. That will be the second agenda for today's session. Okay. Now let's start by discussing the understanding Venn diagrams. Okay. Now already I have discussed in the first session that there are four categorical propositions. One is universal affirmative, that is all x's are y's. One is universal negative, that is no x is y. One is particular affirmative, some x's are y's, and one is particular negative, some x's are not y's. And for each of these four I have shown to you in the video what is the diagram, what is the basic diagram that we make while solving questions. Clear? Now let's understand Venn diagrams by taking this example. Suppose a statement is given that all employees are invited for the program. So this kind of statement that we hear normally in companies, okay, all employees have to do this or all employees have to do that. So let's say all employees are invited for the program. So you see, which type of categorical proposition does this statement belong to? It is an all statement. It talks about the entire set of X, entire set of employees. All employees are there and all employees are invited for the program. So this is an all x's are y's type statement. All x's are y's. Now let's see what is the method, graphical method of understanding this. All employees are invited for the program. Here employees is your x and invited for the program is your y. All x's are y's. Yeah. So all x's are y's, all employees becomes your x, and those who are invited for the program become y. So if you look at the diagram, let's say this is those who are invited. Okay, this circle represents those who are invited. Then where will the circle of employees be? Yeah, the circle of employees will be inside this circle, because all x's are y's means, now we have seen earlier also, I am drawing it again, that x is a circle inside y. Clear? That's how we have made this. This y is here those who are invited for the program, and x is here employees. The circle of employees is inside the circle of those who are invited. That is how we represent real life statements into a Venn diagram using the different types of categorical propositions that we have seen in syllogism. Alright, now we will go to the next statement. Let's take the next statement. Some sport persons play cricket. So which type of statement it is? So if you recall, this is of the type some x's are y's. Now what is x here? The sport person, this is your x, and ry those who play cricket. Some sports persons play cricket. So how do we represent this using a Venn diagram? So we will say let this be the circle of sports persons. Clear? Understand this. This is the circle of sports persons and this is the circle of cricketers. So some x's are y's, x and y are two circles, they have some overlap. So here we have the overlap between sports persons and those who play cricket. Clear? That's how we make the diagram for this particular statement. So what you have to do is that when you get a question, there are 2, 3 or 4 statements given to you, represent those statements using Venn diagrams, and then using the Venn diagrams come up with the logical conclusions. It will become completely clear to you once you follow the examples that I will be discussing with you today. Okay. So let's start with the examples and you will see how everything will fall into place and everything will become completely clear to you. Let's take this example. So this is a typical type of situation of a question of logical reasoning. Now what I want you to do first is to try out this question yourself. Take some time, I'll give it some 30-40 seconds. Look at the question on the screen. Some mobiles are TV, some TVs are computer, all computers are laptops, all laptops are machines. 4 statements are given, followed by 4 conclusions. Some computers are mobiles, some laptops are TV, all computers are machines, no computer is mobile. So you have 4 statements and 4 conclusions. Now we have discussed in detail this Venn diagram for each of the categorical propositions, and I have also shown to you in this video how to make Venn diagrams in these kind of statements. So using that, can you come up with the Venn diagram of all of these statements, the 4 statements which we have, and figure out which of the conclusions follows logically. So you have to find out which conclusion or conclusions, right, follow logically. That means which of these conclusions are logically true, that means which of the conclusions are always true. You have to find that out. So some mobiles are TV. Let's first understand this. We'll take statement number 1. Some mobiles are TV. So we'll make the circle for mobiles. This is a circle for mobiles. Let's call it M. Some mobiles are TV. So some X's or Y's. This is a circle for TV. Okay, so let's understand. The first circle is for mobile and the second circle is for TV, and using the first statement here, some mobiles are TV, we are making this diagram. Some TVs are computers. The TV circle will overlap with the computer circle, right? But you keep in mind that the computer circle is not overlapping with the mobile circle, right? So some mobiles are TV, some TVs are computers, all computers are laptops. So computers will be inside laptops. So this is computer and this is laptop, clear? And then finally all laptops are machines. So first, second and third statement we have done. All laptops are machines. So the laptop circle will be inside this machine circle. So this is a bigger circle here. This is a circle for machines. So some mobiles are TVs, some TVs are computers, all computers are laptops and all laptops are machines. And then we have these conclusions here, some computers are mobiles. So let's start by checking each of the conclusion one by one. So let's start with the first one. Is this conclusion logically true or not? Clear? Now where we have computer, some computer, where is the computer circle? This is the computer circle. And here we have the mobile circle. Are the computer circle and mobile circle overlapping? Can you see that? Computer circle and mobile circle, they are separate, right? This is the mobile circle. This is the computer circle, they are not overlapping. So very clearly we say that this is, what do we say? Do we say this false? There are 3 comments we can make for every statement. Is the statement true? Is the statement false? Or is this statement uncertain? So wherever we know that the statement will be true, it means 100% true, we'll write T there, okay. Where we know the statement will be 100% false, we'll write F there. And where we don't know whether the statement is true or false, we'll write U there, uncertain. Now my question to you is, what do we write here? Do we write T or F or U? Can we say this statement is false? Can we say that? Just see. The mobile circle we know very clearly is not overlapping with the computer circle. So say some computers and mobiles is false. No, it is not false. We don't know. The diagram that you have made is only a tentative diagram. Please understand this. It is a tentative diagram. It is one of the possible diagrams that we can make for this particular case. I'm not going to spend my time or your time also making all the diagrams. We just make the basic diagrams following the statements, and from that itself we can come up with the answer. So listen and understand this one thing. When you have made the diagram using the statements, you can make positive assertions, positive conclusions from the diagram, but you normally don't make negative conclusions. You can say if you see two circles are overlapping, that means clearly they will overlap, there is no doubt about that. But if two circles are not overlapping, it is not necessary that they will not overlap. I will show you here also. Let's see. Let's make a diagram again here. Some mobiles are TV. This is the diagram for some mobiles are TV. First statement. Second statement, some TVs are computers. Can I make the computer circle like this? Some TVs are computers. We can, right? Because ultimately what we need is that TV and computer should overlap. They are overlapping here. It's nothing. It's not going against the statement given to us. But in this particular case, this particular scenario, mobile and computers are also overlapping. So that means there is a possibility. There is a possibility that mobiles and computers can overlap. That is why we put this under uncertain. Please understand this. We don't say it is false, we say it is uncertain. So wherever we have something clearly true, we will write true. Where we have clearly false, where there is no case of overlapping possible, we will write false. Otherwise, when we don't know how two circles are going to relate to each other, we are going to put uncertain. Now let's look at this second statement. Some laptops are TV. You see here the laptop circle very clearly. This is the laptop circle and this is the TV circle. You can clearly see that the laptop circle and TV circle are overlapping. Clear? So that means this is a valid conclusion. Some laptops are TV. There is no doubt about that. This is definitely true. This is definitely true. There is no doubt. There is no discussion on this particular thing. Some laptops are TV is 100% true. Now let's go to the third statement here. All computers are machines. If you look at the circle of computers and look at the circle of machines, you will see that the computer circle is definitely inside the machine circle. That means that the third statement, all computers are machines, is definitely true. There is no discussion about this. There is no doubt about this whether it is true or false. This is definitely right. Now if you look at the fourth statement here, no computer is mobile. Now we have seen earlier that computer circle and mobile circle are not overlapping. Does it mean that they will not overlap? In this case they are overlapping, in this case they are not overlapping. Can we say that they will not overlap? Are we sure about that? No. So what do? We write uncertain. No computer is mobile is also uncertain. So what will be the final answer? We know that 2 and 3 are true. This is definite that 2 and 3 are true. But you understand, we also can say and either 1 or 4 are true. Now this part is very important. Why are we saying that either 1 or 4 are true? This either or is one area which confuses most students. Either 1 or 4 are true. Please understand, whenever we have, this is very important, whenever we have some x's are y's and no x is y as a combination with x and y in any position. So I can say some y's are x's, no x is y. Subject and predicate can change. But if we have some x's are y's and no x is y, if these are given to us and both are uncertain, these are important, very important, both are uncertain. then either of the statements is true. Again, let's recapture. Whenever we are solving a question of logical reasoning and from the conclusions you get some x's or y's and no x's y, combination should be there. Computers mobiles and computer mobile. One has some, one has no. So when we have some x's or y's, no x's y, and both are uncertain. Can you see that? This is also uncertain and this is also uncertain. When both are uncertain, when we have some x's or y's and no x's y as a combination and both are uncertain, then either of the statements is true. Note it down somewhere as a rule and keep it with you. That is why the final answer in this case is that 2 and 3 are true and either 1 or 4 are true. That is the answer for this question. 2 and 3 and either 1 or 4 are true. Clear? Which of the conclusions follow logically? That was the question here. Answer is 2 and 3 and either 1 or 4 are true. We will see some more examples. These things will become more and more clear to you. Let us go to the second example. I have taken only two statements here. Some cars are buses, all buses are trains. This is a little basic question for you to understand. Let us quickly make the diagram here. Some cars are buses. Some cars are buses. All buses are trains. So bus will be inside train. Look at the first conclusion. Some cars are trains. You can clearly see the car circle is overlapping with the train circle. There is no confusion, no doubt. So this statement is definitely true. All cars are trains. You can see the car circle and train circle. Because the relationship car circle is not inside train circle. Does it mean that it cannot be inside train circle? No. Don't write false here, right? Uncertain. Clear? Now let's say a single uncertain uncertain is never the right answer. Okay, so that can never be the part of our conclusion. This also you can keep as a rule. A single uncertain statement is false, or a single uncertain statement will never be a part of the answer. So what will be the answer? Only conclusion one follows. Only conclusion one follows logically. That will be the answer for the second question. Some cars are buses, all buses are trains, and two statements were there. Some cars are trains and all cars are trains. Right? Now we will go to the third question. Again I have taken very simple question for you, and with this question I will be introducing to you the concept of possibility. What do we mean by possibility? Some books are toys, no toys are pots. Some books are toys, no toys are pots. Again let us make the first statement. Some books are toys. So this is book, some books are toys. This is toys. No toys are pots. So this will be pots, and we can make a link here and say no. That means toys and pots will never overlap. Now the question is, which of the following conclusions will follow logically? Can we say no books are pots? You see here, we can see book here and you see pots here. Say no books are pots. It looks like from the diagram that books and pots are not overlapping. But is that true? Are we going to make negative conclusion, negative statements from the diagram? No. We are not sure about it. We are sure that toys will never overlap with pots. But we don't know about books and pots. Books and pots may overlap. Right? So no books are pots is not false. No books are pots is not true. What is it? It is uncertain. All books being pots is a possibility. Let's understand this. What is the meaning of the word possibility in questions of syllogism or logical reasoning? Possibility means something which may be true, may be false. Something which may be true or false. Now, can this be true? Let's ask ourselves this question. All big books being pots is a possibility. Can this be true? Right? Is there any possibility for this particular statement? If it is not, then this will not be the right answer. You understand, there is some part of books is definitely overlapping with toys, and this part of books that overlap with toys can never overlap with the circle of pots, because no toys are pots. That means all books being pots is a possibility is not true, it is false. The first conclusion is uncertain, second conclusion is false, so none follow. What will be the answer? None follow. None of the conclusions follow logically, right? That is how we get the answer for this particular question. None follow. Clear? Now we will go to the next slide. So some players are singers, all singers are tall. Let's see, let's make the diagram and see which of the conclusions follow. Some players are singers. This is a circle for players, and this is a circle for singers. Some players are singers and all singers are tall. So singers will be inside the circle of tall. So first conclusion, some players are tall. Very clearly we can see that the player circle is overlapping with the tall circle. So some players are tall is true. All players are talls, uncertain. Clear? We don't know, it is possible. All players can also be tall, but we don't know, so we will say uncertain. So answer will be only one follows. A single uncertain can never be the answer. So the answer in this case will be only one follows. Next we will look at the previous session contest question. Which of the following conclusions is correct if you are given that only red can be blue? Okay, if it is given to you that only red can be blue. Now which of the categorical proposition does this look like? Does it look like any of the four categorical propositions that we have seen? The four categorical propositions we had seen were all x's are y's, no x is y, some x's are y's, and some x's are not y's. Now think about it, which of the categorical proposition does this statement only red can be blue looks like? So only red can be blue means nothing else can be blue. Does it mean that can green not be blue? No, it means that to be blue sorry, to be blue one must have to be red first. So the blue circle should be inside the red circle. You cannot be a part of the blue circle unless until you are a part of the red circle. Let us say you are a green, there is a circle for green. So green can also be blue if green is inside the red circle, or at least some part of green is inside red circle. So basic idea of this is only red can be blue means all blues are red. That means, please understand, that means only y can be x. only y can be x is a variation of all x's are y's. So, we will be discussing variations in a separate video. Only y can be x is a variation of all x's are y's, correct. So, once we know this particular thing, the moment we see the question only red can be blue, immediately we understand the meaning of this. That means all blues are red. If all blues are red, the meaning of this is that if x is blue, then it must be red, and that is why the answer for this question is B, right. So, we will go to the contest question for this particular session. So, here the contest question is on the screen for you. Look at the statement. There are 3 statements and 3 conclusions. Some pens are erasers, all erasers are pencils, some pencils are boxes, and followed by 3 conclusions here. Some boxes are pens, some pencils are pens, no pen is a box. So, make the Venn diagram. Today we are discussing the Venn diagram method. Make the Venn diagram and find out which of the following conclusions A, B, C, D, which of the following answer options is correct. Here, based on which conclusions follows logically, which of the answer options is correct. Once you have solved, post the answer in the comment section. By now you should have got the answer. Make the Venn diagram properly, and using the Venn diagram you can try and solve the question. Okay, let us see, we will discuss the answer for this question in my next session for syllogism. Let us move on to the next question. Now, problem discussion continued. Some vegetables are fruits, no fruit is black. Again 2 statements, 2 conclusions. Let us find out which of these conclusions is right. Okay. Some vegetables are fruits, very basic statement again. This is the circle for vegetables and this is the circle for fruits. Some vegetables are fruits. No fruit is black. So, again here we have the circle for black, and we know no fruit is black. So, we put a negative link here, no fruit is black. Now, look at the first conclusion. Some fruits are vegetables, very simple. Yes, we can see that clearly from here. Some fruits are vegetables. So, this conclusion is true. The second conclusion, no vegetable is black. You can see the vegetable circle and black circle. We do not have a negative link between these 2 circles. We do not have a negative link. That means that this is uncertain. We do not know whether it is true or false. If I would have used the statement here that some vegetables being black is a possibility. So, if I had used this as one of the answers, one of the conclusions, then this conclusion would have become true, because we do not know the relationship between vegetables and black. So, there is a possibility that vegetables and black can overlap. If there is a conclusion which says all black being vegetables is a possibility, then this would also be true. This also would be true, because we do not know the relationship between black and vegetable. Black has got no such restriction with respect to vegetable. The only thing that is clear is that the fruit circle will never overlap with the black circle. We have no such clarity regarding the vegetable circle and black circle. So, this possibility would also be true. But if we had a statement which says all vegetables being black is a possibility, then this would be wrong. This would definitely be wrong. This is not possible. This would be false. Why it is not possible? Because we know that some part of vegetable overlaps with fruits, and we know fruit will never be overlapping with any part of fruit, will not overlap with any part of black. That means this part of vegetable that overlaps with fruit can never be a part of the circle black. That is why all vegetables being black is a possibility is not right. It is not possible. That is why the answer is false. So, these are some of the advanced conclusions that could be given in a question in today's difficulty level. Okay. So, now we will go to the next question. Now, here we have an advanced level question with variations used. So, statements also, some of the statements I have created in a new way, variations are there. Look at the conclusions also, lots of variation in the conclusions. I will try to solve this question step by step. Some cars are chairs is a basic statement, no variation is there, nothing to worry about this. Only beds can be chairs. Now, as I have explained to you that only y can be x is nothing but another form of saying all x's are y's. So, what will be the correct statement for this? Only beds can be chairs is actually nothing but all chairs are beds. So, this will be the correct statement. Next, at least some beds are flowers. Now, just because we are adding at least here does not mean anything. Basically, it means some beds are flowers. Just forget about this word at least, not required. While solving the question, this is not required. That is just trying to confuse you by adding the word at least. And no flower is plant is a basic statement. No need to worry about what is a variation. That is a basic categorical proposition. So, two variations were there in the second statement and the third statement. Second statement is a variation that many people don't know, that only beds can be chairs actually means that all chairs are beds. The third variation was very simple, at least some beds of flowers is nothing but some beds of flowers. So, let us make the diagram for this particular question. Some cars are chairs. This is car, some cars, and this is chairs, some cars are chairs. All chairs are beds. So, the second statement we have seen that second statement actually means that all chairs are beds. So, chairs will be inside beds. All chairs are beds. Some beds are flowers. So, this will become flowers. And no flower is plant. So, plant will be here. And there is a negative link between flower and plant. Clear? Now, let us look at the first conclusion. Now, is the first conclusion true or false? Can you post the answer here? Is the first conclusion true or false? Some cars can be beds. Look at the diagram here. Look at the diagram that we have drawn, the statements that are given to you, and based on that, can you say whether some cars can be beds? Is this statement true or false? If you look at the car circle and the bed circle, you can clearly see that the car circle and the bed circle are overlapping. There is no doubt about that, right? The car circle and bed circle are overlapping. That means that some cars are beds is true. There is no doubt about this. There is no if and but. There is no case about this, right? Some cars have beds is true. Now the moment we add can be here, it means it is saying possibility. See, any introduction of a possibility based word. Now what a possibility based word in the exams, understand this. If there is a valid conclusion that we know for sure is true, then any of the possibility based words like can be, maybe, or even the word possible, any possibility based words like can be, maybe, or possible makes a true statement false. It converts a true statement into false statement. This is very important. Understand this. We know that some cars have beds is true. The moment we add can be here, this becomes false. We know it is 100% sure, then why are you saying that it is possible? Okay. Now all beds being plants is a possibility. Don't worry about this here. First just look at this statement, all beds are plants. Let me write it here. All beds are plants. Now first you figure out this statement. Don't worry about possibility. First you figure out this split. All beds are plants. Where are beds? Here we have beds. And here we have plants. Can all beds be plant be possible? You see, this part of bed is overlapping with flowers, and we know that flower can never overlap with plants. That means all beds are plants is false. A possibility will not make a false statement false, it will remain false itself. Don't worry about possibility. A possibility cannot convert a false into true. So first statement is false because it was true, and a possibility converted a true statement into false. The second statement is false because it's not possible, right? All beds are plants is not possible, so there is no need to worry about this word possibility. All flowers may be chairs. Again you see this word maybe is there, and maybe is what? Maybe is possibility. So first you focus on all flowers are chairs. Don't worry about maybe. All flowers are chairs. You see, flower and chairs, we don't know the relationship between them, correct? We don't know how these two circles, flowers and chairs, will relate with each other. That means I can say that all flowers are chairs. Forget about maybe now, let's worry about this. All flowers are chairs is uncertain. All flowers are chairs is uncertain. And what does maybe mean? Maybe also means uncertain. Maybe means possibility, and possibility means uncertain. We know that it is uncertain. This statement is also saying this is uncertain. That means this is true. So note here, possibility makes an uncertain statement true. So possibility converts an uncertain statement into true statement, and we know that it converts a true statement into a false statement. Clear? So these points you have to keep in mind. So 3 is first, second, third we have seen. One true statement we have got. Now let's look at the fourth statement. Not even one car is flower. Not even one car is flower is another way of saying no car is flower. This is also a variation. No car is flower. Now you think about whether this statement is true, false, or uncertain. No car is flower. Here we have car. Here we have flower. You see, car and flower circle are not overlapping, but will they overlap or not overlap? We don't have any clarity. So we'll say this is uncertain. Now at least one flower is car basically converts into some flowers are cars. You see here again, flower circle and car circle don't overlap, we have no clarity on them, so this statement is also uncertain. Two uncertains we have which are the form no and some. So this I have discussed earlier, when we have some x's or y's and no x is y, when we have a combination of these two and both are uncertain, then either is true. Clear? So answer will be either 4 or 5 will be true. So we will say what is the answer. Now remember here, first one is false, second is false, third is true, 4 or 5. So we know the first one is false, second one is false, third one is true, fourth is uncertain, fifth is uncertain, and that becomes either or situation. So final answer will be 3 and either 4 or 5 are true. This is the final answer. Third conclusion is true and either 4 or 5 are true. Now this is reflecting the kind of difficulty level that you will see today. That means variations are there. You see, variations are there in the statements also. Variations are there, can be, maybe, not even one, at least one. Variations are there in the conclusions also. So both things I have covered for you here, variation, how to handle variations and how to handle this possibility based questions, right. So observe carefully the way I have approached the question and note it down somewhere properly, and then try solving the question again. Look at the video once more if you have doubt, and that will confirm that you have understood this particular topic. So now the time is for the CPP. So from this level of difficulty I have selected 10 questions for you which will test all of these things while solving questions, how to make Venn diagrams and solve. Clear? So those who have passport access, once you hear the sound, start solving the questions and use Venn diagram method only. Don't use any other technique, use Venn diagram method for solving the question. Best of luck to you. The question which you get wrong I will be discussing in my next session.